Okay, ladies and gentlemen, let's start graphing in 3 dimensions. Let's start graphing in 3 dimensions. Normally, we have a distance formula of 1, 2, and 3, 5. Okay, 1, 2, 3, 5. And we would find the distance saying x2 minus x1 quantity squared plus y2 minus y1 quantity squared. We would say 1 minus 3, the quantity squared, plus 2 minus 5, the quantity squared, square root. That's what you would do, and you would come up with an answer. But in 3 dimensions, instead of just x and y, you're going to end up with 1, 2, 4, 3, 5, -1. And now we have x, y, z, x, y, z. And to graph that, I'm going to have a little different screencast video. Hey, buddies! And I will show you how to do that using the computer. But the short version is you have the y-axis, the x-axis, and the z-axis. Now, your book may put them in a slightly different order than I put them in, but that's how I would go ahead and do it. In this case, I want to move along the x 1 unit. Then I want to go up 1, 2 units. Then I want to go forward 1, 2, 3, 4 units. So that's where I would graph that point. If I were to graph a different point, 3, 5, -1, 1, 2, 3, 1, 2, 3, 4, 5, and back 1, that would put this point back here. So that's how you graph in 3 dimensions. If it makes it easier to see, it's like a box. And that box, it's like going along the back edge of the box, up the side of the box, and forward. 3 dimensions is hard to visualize, but I think you can try it. I'm also going to have a computer problem to show you how to do that. But I can do distance in 2 dimensions. I can also do distance in 3 dimensions. All I have to do is add one of the variables. x2 minus x1 quantity squared plus y2 minus y1 quantity squared plus z2 minus z1 the quantity squared. The reason we do the distance formula here is because hypotenuse equals leg squared plus leg squared square root. Really what you're doing is the Pythagorean theorem turns into the distance formula, and now we're just taking it from 2 dimensions to 3 dimensions. So 1 minus 3, 2 minus 5, 4 minus -1, squared plus squared plus squared, square root, and that's how you would find your value. Now, we could also do a midpoint. Midpoint is normally x1 plus x2 all over 2, comma, y1 plus y2 all over 2. But for 3 dimensions, it has to have 3 parts, so we're going to go comma z1 plus z2 all over 2. You can plug those points into here, work them out, and you'll have number, comma, number, comma, number, and that's your 3-dimensional point. It should be halfway. Okay, let's see what we can do with 3-dimensional distance and midpoint.